We've got a circle with centre 0, 0. We've got a straight line with negative gradients. We're told that they intersect at A and B. We've been given the coordinates of A and the x-coordinate of B, and we need to work out the equation of the line. Now, I've already started drawing a little sketch of this situation just to help me picture what's going on. You can see I've drawn a set of axes, and I've drawn a blue circle that's got a centre 0, 0. I'm now going to draw a straight line going through the points A and B that are also on the circle. So the coordinate of A is -9, 2, which is roughly over here. This is just a sketch, doesn't have to be accurate. So this is A, which has got the x-coordinate of -9 and the y-coordinate of 2. Then we had the x-coordinate of B being 7. So 7, I think, is like roughly here, which means that B could be here maybe, or it could be down here. Now, I don't think it's going to be the one on the top. I don't think that, because if it was, then my straight line is going to have a positive gradient. And I know it's supposed to have a negative gradient. So I don't think B is there. I think B is actually down here, where the x-coordinate is 7 and we don't know what the y-coordinate is yet. And we want to work out the equation of the line that's going through those points. This is my line here. Right, well, equations of circles that have a centre on the origin always look like this. X squared plus y squared is equal to the radius squared. That's the general equation of a circle when the centre is on 0, 0. And because we know that point A lies on the circle, we can substitute that into our equation. The x-coordinate is -9. The y-coordinate is 2. We don't know what the radius is. We're going to work that out. The -9 squared is a positive 81. The 2 squared is 4. So the radius squared is 85. And the radius, should we want it, is √85. Not that we actually particularly need it for this question. We need the equation of the circle, not necessarily the actual radius itself. So the equation of the circle is x squared plus y squared is equal to the radius squared, and we now know that that radius squared is 85. So that's the equation of the circle. And because point B is on the circle, we can use the equation of the circle to help us work out the other coordinate of B. We know the x-coordinate is 7, but we don't know the y-coordinate. 7 squared is 49. Take the 49 away from both sides, so that 85 take away the 49 is 36. So y is either +6 or -6. And hopefully you can see from the diagram that it's going to be -6 that we want for point B. The +6 would have been the point that was up here that we discounted earlier. Right, now we've got both coordinates of A and B. We can work out the equation of the line going through them, doing y equals mx plus c. Let's work out its gradient first of all. So the gradient is going to be the change in the y divided by the change in the x. So let's look at the y coordinates. We're going to do the change in the y coordinates, so minus 6 minus the 2. Then we're going to do the change in the x coordinates. So 7 minus the minus 9. So minus 6 minus 2 is minus 8. The 7 plus 9 is 16. So the gradient is minus 1/2. So we can say that y equals minus 1/2 x plus c. To work out our y-intercept, we can use either of our coordinates. I'm going to use this coordinate here. So I know that the y coordinate is minus 6 when the x coordinate is 7. So minus 6 is equal to minus 1/2 times 7 is minus 3.5 or minus 7 over 2. I'll add 7 over 2 to both sides. Now, in order to simplify that, we need a common denominator, so that minus 6, we'll write that as minus 6 over 1, which is then going to be the same thing as minus 12 over 2. And the minus 12 over 2 plus 7 over 2 is minus 5 over 2. So we've got the y-intercept now, and we've now got the full equation of the straight line, which is y equals minus 1/2 x minus 5 over 2. And we can leave our answer like that because the question didn't specify how we had to leave our answer.